Hi, my name is Shivakumar. I'm a first fourth year BTech, and today we'll discuss about some topic in flexible AC transmission systems. In these systems, we have to discuss about the series and shunt compensation systems. First, series compensation system. Series compensation is basically a power tool to improve the performance of the high voltage lines. It consists of capacitors connected in series with the line with suitable locations. Advantages of series compensation increase the transmission capacity and power transfer without the and with compensation. Improvement of system stability. For the same amount of power transfer and the same value of energy and voltage, the phase angle case of series compensation line is less than the uncompensated line. Therefore, P equal to EV by XL sin delta. A lower power means better than the system stability. Series compensation offers the most economic solution for system stability as compared to other methods like reducing generator, excavator reactance, bundled conductors, increase in number of the parallel circuit, load division between the parallel circuit. When the system is to be strengthened by the addition of new line or when the one of this existing circuit is to be adjusted for the parallel operation in order to achieve the maximum power transfer and minimize the losses, series compensation can be used. Observed to the Sweden, that is the cost of the series compensation in 420 kV system was entirely recovered due to the decrease in losses in 220 kV system operating in parallel with the 420 kV system. Less installation time. It takes the less installation time means the series capacitor is smaller, approximately 2 years, as compared to the installation of parallel capacitor. It takes the 5 years. It reduces the risk factor and hence it hits the current thermal limit. The life of exmission line and capacitor generally 25 years. The main disadvantage is fault current is increases and maloperations of distance relay if degree compensation and locator is not proper. High recovery voltage of lines across the circuit breaker contacts and is harmful. Problems of ferro resistance. When a unloaded or lightly loaded transformer is energized through the series compensator line, ferro resistance may occur. It produced due to the resonance occurred in between the iron created inductance and the reactance is compensated line. This will cause the flow of high current. It rarely happens, may be suppressed by using shunt resistors across the capacitor or by a short circuiting and the capacitors are temporarily through an isolator or bypass breaker. Problems due to the subsynchronous resilience. The series capacitor's introduced subsynchronous frequency is proportional to the square of the root compensation in system. In some cases, this frequency may interact with the weak steam turbine generator shaft and give to rise to high torsional stress. In hydro turbine generators, the risk of the subsynchronous resonance is small because of the torsional frequency is about of the 10 Hz or even less. Subsynchronous resonance. We know that the series composition uses the power handling capacity of the line P equal to EV by X and X equal to XL, the difference between the inductance and capacitance reactance, where the K is the degree composition and the F is the frequency and the subsynchronous, the location of the series capacitor. The choice of the location of the series capacitors depends on the main technical and economical consideration. In each case, the special system study concerning load flow and stability, transient voltage, protection requirement, system voltage profile, etc. is necessary before the optimal location is filled. Location along the line. In this method, the capacitor bank is located at the middle of the line or 1/3 of the distance along the line. This has advantages, better voltage profile along the line, less shorter circuit breaker current through the capacitor in the event of the fault and simple protection of the capacitor. The capacitor stations are generally unattended. Location at the both location at the one or both ends of the line section of the line side in switching station. The main advantage of this location can be capacitor installation is near the manned substations. However, requires more advanced line protection. For the same degree compensation, more MVA capacity is needed for the as compared to the method. Location within the bus bar switching the shunt compensation. For high voltage transmission line, the shunt capacitance is high and plays significant role in high voltage conditions at the receiving end. When the line is loaded, then the reactive power demand of the load partially met by the reactive power generated by the line capacitance, and the remaining reactive power demand is met by the reactive power flow and through a line from the sending end to the receiving end. When the load is high, the large reactive power flows from the sending end to the receiving end, resulting in a large voltage drop across the line. To improve the voltage at the receiving end, shunt capacitors may be connected at the receiving end to generate and feed the reactive power to load so that reactive power flow through the line and consequently the voltage drop of the line is reduced. Shunt compensation. If the XL is equal to the reactance of the shunt reactor, then the voltage amperes are observed to the reactor. When the load is small, then the load reactive power demand may be even lesser than the reactive power generated in the line capacitor. Under this condition, the reactive power flow through the line becomes negative. Is that reactive power flows from the receiving end, sending end, and receiving end voltage is higher than the sending end voltage. To control the voltage at the receiving end, it is the necessary to observe or sync the reactive power. This achieved conducting shunt reactors at the receiving end. Thanks for the giving this opportunity.